Good evening, everybody. So today we'll discuss about acid, bases, and salts. In this chapter, you learn define the terms acid, base, and salt. Give examples of some common household acids, bases, salts. Describe the properties of acids and bases. Explain the types of solutions. Explain indicators and alkalis. Define pH. Recognize the importance of pH in everyday life. Define salts and describe their methods of preparation. Uses of baking soda, washing soda, plaster of Paris, and bleaching powder. So let us study about the history of acids and bases. It was first used in the 17th century by Robert Boyle to label the substances as acids and bases. So it is a Robert Boyle who has divided the substances into two categories, that is acid and bases. So let us study what do you mean by an acid and base. An acid is a substance which furnishes hydrogen ions when dissolved in water. So, what is an acid? A substance which always furnishes hydrogen ions. At the right side, you can see a blue color beaker, right? So, it is having H plus Cl minus. So, HCl is nothing but an acid. So here the hydrochloric acid is having the free H plus ions. It means that it can furnish the hydrogen ions in a water when it is dissolved in water. So we can say that HCl is an acid. Bases. A base is a substance which furnishes hydroxide ions, that is OH minus ions when dissolved in water. So similar to acid here, the bases are also a substances, but they furnish OH ions. So here you have a green color beaker at the above diagram, right? So Na plus and OH minus ions. So here NaOH is a base, that is sodium hydroxide is a base. When it is dissolved in water, it will furnish hydroxide ions, that is OH minus ions. So any substance which gives free OH ions, we can say it is a base. So we understood what do you mean by acid and bases. Now we will see some of the examples of acids. So first and foremost example, hydrochloric acid, that is its molecular formula is HCl. It is usually produced by the stomach in a juice, that is gastric juice. It is in a gastric juice produced from the stomach of our body. Next one is carbonic acid. So we know so many examples for soft drinks, right? We will drink soft drinks. So the soft drinks basically contain some acid content. It is not a very concentrated acid. It is a mild acid. That is, it consists of carbonic acid. Its molecular formula is H2CO3. What is the formula? That is H2CO3. Next, we have ascorbic acid. And another example for acid, we can say ascorbic acid. It is for a chemical name for vitamin C. It is usually present in most of the fruits and also in lemon. So we have vitamin C content in most of the fruits. That is nothing but that is ascorbic acid. Next, we have citric acid. So we have listened about citric acid. It is the main constituent of most of the oranges and lemons. Citric acid is a main constituent of oranges and lemons. Acetic acid. So acetic acid is also present in vinegar. So it is also an example for a mild acid, acetic acid. It is present in a vinegar. Lactic acid, we all use it daily in our daily life. that is, it is present in curd, which is formed from lactose sugar present in the milk. So we all use the curd. Milk turns into curd, right? Curd is sour in taste. It is because of the presence of acid, that is lactic acid. Next one is nitric acid. So very good example, nitric acid, very strong concentrated acid, that is HNO3. Another is concentrated acid, that is sulfuric acid, that is H2SO4. So these two are the acids which are mostly used in laboratories. Let us see some examples of bases. So first and foremost, that is sodium hydroxide. It is also used as caustic soda. It is caustic soda which is used in washing soaps. We use it in a washing soaps. Secondly, we have potassium hydroxide, that is KOH, and its common name we can say it is potash. It is used in bathing soaps. Potassium hydroxide is used in the bathing soaps. Thirdly, we have calcium hydroxide. The common name of calcium hydroxide is lime water, which is used in whitewash. Fourth, we have magnesium hydroxide, that is MgOH taken twice. The common name of magnesium hydroxide is milk of magnesia, that is, which is used to control acidity. Whenever we eat some oily substances, we suffer from acidity. So to control it, we usually take milk of magnesia, the tablets which consists of magnesium hydroxide. Next, we have ammonium hydroxide. Its molecular formula is NH4OH. It is used in hair dyes. We know most of the hair dyes which consists of ammonium hydroxide. So these were some of the bases we have discussed. Next, we will move on to the very important part, that is differences between acids and bases. Let us understand what is the basic difference between acid and bases. Acids are sour, gives burning sensation. They are generally sticky, reacts with the metals to produce hydrogen gas. So acids are stored in glass bottles, right? So whenever we see the acids, they are usually sour and they give burning sensation. Whenever they fall on our skin, it causes the burn, and they are highly sticky. They react with all the metals to produce a hydrogen gas. So only we store the acids in a glass bottles. You might have seen in laboratories, we store the acids in glass bottles. Bases are opposite, as they are bitter. They are not sour, they are bitter to taste. They are generally odorless, that is, they do not have any smell. We have an exception for this, that is ammonia. We'll get a bad smell with ammonia, right? But all the bases are odorless. They are slippery. When we touch, their texture are slippery. Bases reacts with the fats and oils. They only react with the fat and oils. So bases can be stored in any container. We have an exception with acid. We have to store them in glass bottles only, whereas we can store the bases in any type of a container since they are not reactive. We will understand what do you mean by indicators. Very important. There are many substances that show one color in an acidic medium and another color in a basic medium. Such substances are called acid-base indicators. So what are indicators? They change their colors with respect to the medium they fall, right? If they are present in acidic medium, they show one color. If they are present in basic medium, they show another color. Such kind of substances, we call them as indicators. So at the right side, you have an examples of indicators. So methyl orange, you have an example of a methyl orange, right? So whenever you add the methyl orange in a pH range, say that is 3 to 4, that is, you say it is an acidic medium, it will change its color from red to yellow. So it is one of an acidic indicator. It will change the color from red to yellow. Next one, you have bromothymol blue. It is another indicator of pH range that is 6 to 7.6. It will change its color from yellow to blue. The very important, most commonly used indicator, that is phenolphthalein, most probably we'll use in the labs. So it is one of a base indicator. So when it is in a pH of 8 to 10, it will change its color, that is from colorless to pink. So it is one of a base indicator. Fourth, we have litmus. So litmus is actually in a form of a paper. You have red litmus and blue litmus. So it will indicate a pH from 5.5 to 8.2, that is both acid as well as a base. It will change the color from a red to blue. That is, if it is a base, it will change from red to blue. If it is an acid, it will change from blue to red. Next one, we have bromocresol green. So it has a pH range from 3.8 to 5.4. It will change its color from yellow to blue. Lastly, you have indicator that is thymol blue. So it is having a pH range from 8 to 9.6. It will change its color from yellow to blue. So these are some of the examples of indicators. The most commonly used indicator is a litmus paper. We usually use the litmus paper since it has both the acidic and basic indicators. So litmus is actually obtained from a organism that is a lichen. It is obtained from the lichen. It is a synthetic indicator. We use it in a lab. So these were about indicators. Let us understand what do you mean by alkalis. Very important concept, alkali. The bases which are soluble in water. The bases which are soluble in water and give hydroxyl ions in their aqueous solution are called as alkalis. What are alkalis? The bases which are soluble in water and give hydroxyl ions, those are called as alkalis. Now we will move on to the next important topic, that is solutions. So we all know what do you mean by solution. That is, solute plus solvent togetherly forms the solutions, right? So we have three types of solutions. What are those? That is neutral, acidic, and basic solutions. We have three types: neutral, acidic, and basic. Let us see what is the difference between them. So neutral solutions. It is a solution in which we have hydrogen ion and hydroxyl ion in an equal proportion. We have an equal concentration of hydrogen ion and hydroxyl ion. We can say a neutral solution is the one which has equal concentration of hydrogen and hydroxyl ions. Yes, you have a diagram. The center one indicates the beaker, that is neutral solution. You can observe the hydroxyl ions are exactly equal to the hydrogen ions here. Such kind of solution is called as a neutral solution. Next one, we have acidic solution. What do you mean by acidic solution? If in a solution there is a high concentration of hydrogen ions than the hydroxyl ions, if we have high concentration of hydrogen ions than the hydroxyl ions, we can say it is a acidic solution. You can observe the first beaker indicates the acidic solution. We have almost more than 5 hydrogen ions, whereas we have only 2 hydroxyl ions. Such kind of solutions is called as a acidic solution. Next, we have basic solution. Basic solution are the one quite opposite to the acidic, which have high concentration of hydroxyl ions than the hydrogen ions. So the last beaker in the diagram indicates the basic solution. So it has more hydroxyl ions than the hydrogen ions. So these were the three important solutions we have studied. Next, very important concept we learn about pH and its importance. So pH is one of a notation which was been devised by the Danish biochemist Soren Sorensen in the year 1909. So it is one of a notation we can say pH which was been given by a Danish biochemist. So what do you mean by pH? pH is nothing but it is negative of logarithm of hydrogen ion concentration. It is negative of logarithm of hydrogen ion concentration. So we can say that pH basically indicates the hydrogen ion concentration of a solution. So let us see in a form of a pH scale. So here below you can see the pH scale. So if the pH is from 0 to 6, you have 0, 1, 2, 3 up to 6, then such kind of solution we can say it is acidic. Since it is negative logarithm, so lower the hydrogen concentration, greater the acidity of the solution. Lower the pH, greater the hydrogen ion concentration, right? So since it is negative from 0 to 6, we can say it is a acidic solution, whereas if the pH indicates a 7, we can say that here the hydrogen and hydroxyl ion are equal in concentration. It is neutral. It is a neutral solution. If the pH indicates from 8 to 14, we have a readings on the pH scale up to 14. If it indicates from 8 to 14, then it is a alkaline solution. In another way, we can say it is a basic solution. So here we can say greater the pH, more the basicity of the solution. We will see the importance. pH plays a very important role in our daily life. So let us see some of the importance of pH in everyday life. So first and foremost, acid rain. So we have already studied about acid rain. We can say a rain which has a high concentration of acidity in the form of sulfuric acid. So here the acid rain which is having acidity means the pH is low will affect the survival of aquatic life. The survival of the aquatic life become difficult if there is a acid rain. So if the pH of the rain decreases, the survival of the aquatic life becomes difficult. Secondly, pH in plants. So pH plays a very important role in plants. How it is? Plants have a healthy growth only when the soil has a specific pH range, right? If the soil has a specific pH, if it is acidic soil, the plants cannot grow. If it is completely basic also, they cannot grow. So they require a specific pH range. Next, it also plays a very important role in digestive system. Stomach produce hydrochloric acid. So our stomach produce an acid that is hydrochloric acid, which helps in the digestion of the food. It will help in the digestion of food. But too much of acid which causes acidity. So if it is a high concentration of hydrochloric acid in our stomach, it results in acidity, and we can cure it by taking that is milk of magnesia. It is also called as a magnesium hydroxide, right? So pH has a positive role as well as a negative role. Since it helps in digestion, at the same time, if it increases more, it leads to acidity. It also plays a very important role in the self-defense of animals and plants. So let us see how it is. Bee sting. So we all know about bee sting. Causes severe pain and burning sensation. So when they bite us, it will cause a severe pain and burning sensation. It is due to the presence of methanoic acid, that is CH3COOH. What is bee sting? It consists of a specific chemical, that is methanoic acid, due to which CH3COOH. So it is a methanoic acid. Yeah. So because of the methanoic acid which has been released by the bee stings, it causes a severe pain and burning sensation in our skin. Secondly, we have tooth decay. The unclean mouth encourages the bacterial activity which further lead to the acidic condition, that is about pH 5.5. Degradation of the tooth enamel, which leads to the degradation of tooth enamel, that is the hardest substance in the body. So pH plays a very important role to keep our tooth very properly. It is because if the bacterial activity encourages in our mouth, it leads to acidic condition, which leads to degradation of our tooth, which is one of the hardest substance of our body. Next, we will see the pH in humans and animals. It also plays a very important role in humans and animals. That is, most of the biochemical reactions taking place in our body are in a narrow range of pH, that is 7 to 7.8. So even our body has to maintain a particular pH condition, that is about 7 to 7.8, to take place all the biochemical reactions. Say for example digestion, or you can say circulation. Even the blood also should have a particular pH to be maintained. So almost all the biochemical reactions require a particular pH range. So this is what we have discussed about the importance of pH. Next we will see about salts. Salts are ionic compounds. They are basically ionic compounds made of cation other than hydrogen ion and an anion other than hydroxyl ion. So a salt doesn't consist of a hydrogen ion and a hydroxyl ion, but it is made up of a cation and a anion. Together it forms the salt. So we can say salt is an ionic compound. So let us see the formation of salts, the mechanism behind the formation of a salts. So firstly, the formation of salt is by the neutralization of acids and bases. So for example, you have, what do you mean by neutralization? Whenever an acid reacts with the base, the reaction is called as a neutralization. So here you have an example. When a base reacts with an acid, it results in a formation of a salt plus water, right? So here we have taken example for base is NaOH, that is sodium hydroxide, which reacts with the acid, that is hydrochloric acid. It results in a formation of a salt, that is sodium chloride. Here sodium is a cation, chloride is a anion. So here we can say ionic compound is a salt. Results in a and also it releases the water molecule, that is H2O. So this is how we can form the salts, by the neutralization of acid and bases. Secondly, we have the formation of salts is by the action of acids on metals. We can also synthesize the salts by the action of acids on metals. In a reaction between an acid and a metal, salt is produced along with the hydrogen. So how it is, we will see with the help of an example. Here we can say when metal reacts with an acid, any metal, if it reacts with any acid, It results in a formation of a salt and hydrogen gas has been released. Let us see an example. I have taken an example metal, that is zinc. Here zinc reacts with an acid, say sulfuric acid, that is H2SO4. It results in a formation of zinc sulfate, that is a salt, ZnSO4, with the release of hydrogen gas. So here we have formed the salt, that is zinc sulfate, by the reaction of a metal with an acid. Next one, by the action of acids on a metal carbonates or a hydrogen carbonates. We can also synthesize the salts. How it is? Salts are produced in the reaction between acid and a metal carbonates and a hydrogen carbonates. So generally, we have a reaction when a metal carbonate, you can say any metal carbonate, if it reacts with any of the acid plus acid, it will give rise to a salt plus water with the release of gas, that is carbon dioxide. We will see a specific example for it. So here we can take a metal carbonate, that is calcium carbonate. Here in calcium carbonate, metal is calcium and it is a carbonate. You can also take the sodium carbonate. Even we can take the potassium carbonate, any metal carbonate. It will react with an acid, that is HCl, it is hydrochloric acid. It results in a formation of calcium chloride. It results in a formation of calcium chloride, CaCl2. It is a salt. If you have taken sodium carbonate, it results in a formation of sodium chloride. It is also a salt. Plus, it forms water, that is H2O, and carbon dioxide, that is CO2. So this is how we have seen the formation of salts, some of the important mechanism for the formation of salts. Next, we will see some of the commonly used salts. So firstly, that is baking soda. Some of the uses of baking soda. Baking soda is commonly used for cooking of certain foods. We have studied it is used for the cooking of certain foods. Even in bakery items also we use a baking soda. It is also used in medicines. Baking soda is used in medicines to neutralize excessive acid in the stomach and provide relief. So it is used as an antacid. Even in medicine, it is used as antacid. Even baking soda is also used in soda acid fire extinguisher. So to extinguish the fire, we use soda acid fire extinguisher, which uses the baking soda. Next one, that is washing soda. So we have two important salts, that is baking soda, washing soda. That is washing soda chemical name, sodium carbonate. We have baking soda, sodium bicarbonate. So here we will see some of the uses of washing soda. It is used in the manufacture of caustic soda, glass, soap powders, borax, and in the paper industry. Secondly, washing soda is used for removing the permanent hardness of water. So it is used for the removal of hardness of water. That is softening of the water. It is used as a cleansing agent for domestic purpose. So domestic purpose also we use the washing soda. So there are some of the uses of washing soda and baking soda. We will see next important salt, that is plaster of Paris, that is POP. We will see some of the uses of POP. It is used in making casts for manufacture of toys and statues. So you might have seen the toys and statues, that is basically some of the festivals also. For the preparation of statues, they use the plaster of Paris. It is also used in medicine for making plaster casts to hold fractured bones. So if there is a fracture of bones, we use POP in place while they set. It is also used for making casts in dentistry. So here the POP is being used for setting of the fractured bones, and also it is used in the dentistry. So we will see how it is. How does this POP works? So here the POP is because of the basically a substance called gypsum. That is gypsum. You can see what is the chemical formula of gypsum? That is calcium sulfate decahydrated. That is CaSO4 2H2O. This is actually a chemical formula for gypsum. It is in a form of a powder. So when this gypsum is been heated at a temperature of 373 Kelvin, very high temperature, say 100 degrees Celsius we can say, when it is heated at 373 Kelvin, it results in a formation of a very strong substance, you can say, that is plaster of Paris, that is POP. So what is POP? That is CaSO4 half H2O. When gypsum will lose 3 by 2 of its water molecule, that is 3 by 2 H2O, you can see here 3 by 2 H2O is been released. When we heat the gypsum, if it loses 3 by 2 H2O, the resulting compound is the plaster of Paris. It is used for plastering the fractured bones. POP is also used. It is also used for making the surface of walls and ceiling smooth. So it is also having application of the making of surface of walls and ceiling smooth. It is also used for making decorative designs on ceiling, walls and pillars. You might have seen some of the decorative designs on ceilings, walls and pillars. It is by the use of POP. It is also used for making the fireproof materials. Since it is a very hard material, it is also used for making the fireproof materials. So next we will go for the very important salt, that is bleaching powder. So here bleaching powder is used in textile industry for bleaching of cotton and linen. So it is used in textile industry for bleaching of cotton and linen. It is also used in paper industry for bleaching of wood pulp. So basically it is having a bleaching activity. It is used in paper industry for bleaching of wood pulp. It is also used in making wool unshrinkable. So to make the wool unshrinkable, we use the bleaching powder. It is used as disinfectant and germicide for the sterilization of water. So we add the bleaching powder to remove the germs and also to make the water sterilize. So it is used as a germicide and disinfectant. It is used for the manufacture of chloroform. Bleaching powder is used for the manufacture of chloroform. And lastly, it is also used as an oxidizing agent in chemical industry. So it has a very much application in chemical industry as an oxidizing agent. So these were some of the uses of bleaching powder and some of the uses of salts. Now we will move upon to the very important part, that is question answers. So first one, what is milk of magnesia chemically? So what is milk of magnesia? Chemically it is called as, is it a magnesium carbonate or sodium bicarbonate or calcium hydroxide or magnesium hydroxide? So any answers? What is milk of magnesia? Magnesium carbonate, sodium bicarbonate, calcium hydroxide, or is it a magnesium hydroxide? Okay. So the answer, that is fourth option, that is magnesium hydroxide. We have studied magnesium hydroxide is nothing but milk of magnesia. So magnesium hydroxide is an inorganic compound with a chemical formula that is MgOH taken twice. As a suspension in water, it is often called milk of magnesia because of its milk-like appearance. Why it is called milk of magnesia? It looks like milk when it is dissolved in water. The acid rain destroys vegetations because it contains. So we have studied about acid rain. What does it contains basically, right? Is it consists of nitric acid, ozone, carbon monoxide, or sulfuric acid? It is fourth option, that is sulfuric acid. Acid rain is caused by the emissions of sulfur dioxide and nitrogen oxides, which react with the water molecules in the atmosphere to produce acids. So whenever the sulfur dioxide SO2 and nitrogen oxide NO reacts with water, it results in a formation of acid. So basically acid rain consists of more concentration of sulfuric acid. An acid reacts with the substance Z. So they are telling an acid reacts with a substance, say it is Z, with the liberation of carbon dioxide gas. What can be the nature of Z? So you have to guess what is Z here, right? Is it a metal carbonate? Is it a metal bicarbonate? Is it a metal oxide or non-metal bicarbonate? So when acid is reacting with the Z, it is releasing the gas, that is carbon dioxide. What is the nature of Z here? So any answers? Metal carbonate, metal bicarbonate, metal oxide, non-metal bicarbonate. Okay. So we have the answer, that is first option, metal carbonate. So here we have an explanation, that is we have reaction. We have studied, that is metal carbonate. You can say any metal carbonate, ZnCO3 or NaNO3. Metal carbonate reacts with the acid. It results in a formation of a salt plus water and carbon dioxide. So here Z is reacting with acid. So Z is a metal carbonate. Okay. Milk tastes sour when kept in the open for some time due to the formation of lactic acid, citric acid, acetic acid, or carbonic acid. Whenever we keep the milk open for some time, it gives a sour taste. Because of which of the following acids? Is it lactic acid, citric acid, acetic acid, or carbonic acid? Okay, so it is because of the presence of, that is lactic acid. Option 1, lactic acid. Okay, we have an explanation. Like many other things, milk contains bacteria, right? Like other things, milk also contains bacteria. Milk also naturally contains a kind of a sugar known as lactose. Milk has a sugar called as a lactose. When the bacteria use the lactose sugar to produce, that is, they use the lactose sugar to reproduce, they change it from lactose sugar into lactic acid, which tastes sour. So here bacteria will use the lactose sugar to reproduce and convert it into an acid, that is lactic acid. So milk tastes the sour taste. Fifth one, the most suitable vessel for storing concentrated sulfuric acid is. So we know that acids are very corrosive in nature. So which vessel we will use to store it? Copper vessel, aluminium vessel, glass vessel, or earthen vessel? So which of these vessels we will use to store the sulfuric acid? Okay. Any answers? So which of these vessels are being used to store the sulfuric acid? That is concentrated sulfuric acid. Okay. So the right answer is glass vessel. That is option 3, glass vessel. So we have studied about it. Concentrated sulfuric acid can only be stored in glass. No metal lids, some plastic containers. We cannot use any metal lids or plastic containers. The good thing is it will not start a fire, but if it goes into contact with the metal, it may generate the hydrogen gas and explosion risk. So if you leave it for a long time, it may generate the hydrogen gas with other containers and leads to the explosion. So we should store it always in a glass vessel. Okay, sixth one we have pH value between 6.5 to 7.5 makes the soil. Does it makes the soil basic, neutral, acidic, or none of these? So here we have a pH range from 6.5 to 7.5. Okay. Okay, we'll see the answer. That is, it is the option 4, none of this. So it is neither acidic nor it is a basic, and if it is not 7 also, it is neutral. So none of this option. Solutions with the pH less than 7, if it is less than 7 are said to be acidic. And the solutions with the pH greater than 7 are called bases or alkaline. A pH of 7, exactly 7, is treated as neutral. So here it is neither below 7 nor above 7 or exactly 7. So the option is none of this. Baking soda is. So what is a baking soda chemical name? Is it is a potassium carbonate, sodium hydroxide, sodium carbonate, or sodium bicarbonate? So which of these options is a baking soda? Okay, we'll see the answer. That is the fourth option, that is sodium bicarbonate. So chemical name for baking soda is sodium bicarbonate, whereas washing soda is sodium carbonate. We'll see the explanation. Baking soda is sodium bicarbonate or sodium hydrogen carbonate. It is also called as sodium hydrogen carbonate. It is primarily used in cooking, that is baking, as a leavening agent. It is used as a leavening agent in basically in baking process. Okay, vinegar is a commercial name of. So we heard about vinegar. It is a commercial name of which of the following acid? Is it oxalic acid, hydrochloric acid, or acetic acid, or fourth one, citric acid? So vinegar is a commercial name of oxalic acid, hydrochloric acid, acetic acid, or citric acid. Okay, any answers out of this? Which is a commercial name for vinegar? Okay, we'll see the answer. So it is option 3, acetic acid. Vinegar is a liquid substance consisting mainly of acetic acid. We have a formula, chemical formula for acetic acid, CH3CO2H, or you can also say CH3COOH, both are true, and water. The acetic acid being produced through the fermentation of ethanol by acetic acid bacteria. It is today mainly used in kitchen as a general cooking ingredient. So it is also used in a kitchen. We have heard about using of vinegar in kitchen, right? So it consists of a mild acid, that is acetic acid, which is produced through the fermentation of ethanol. It is produced by the fermentation of ethanol by the help of acetic acid bacteria. Okay, Taj Mahal is greatly affected due to. So we heard about Taj Mahal. It is greatly affected due to tourist, acid rain, deforestation, or sound pollution. It is one of a historical monument. It is affected by which of these four following, right? Okay, so we'll see the answer. It is affected by the second option, that is acid rain. When the sulfur pollutants fall onto buildings made from limestone and sandstone, they react with the minerals in the stone to form a powdery substance that can be washed away by the rain, and this is known as acid rain. So whenever the acid rain falls on the Taj Mahal, it loses its lustrous property. It is because of the sulfur pollutants which falls on the building. Next one we have litmus is obtained from. So we have studied what is litmus. It is one of an indicator, right? So it is obtained from which of these following? Is it from a bacterium or a fungus or an alga or lichen? From which of these organisms we obtain the litmus? Bacterium, fungus, alga or lichen? We have discussed about it, right? So any answers? Which of these are used to obtain the litmus? So we'll see the answer. Fourth option, lichen. We have an answer, that is fourth option, lichen. Because lichen is a one of a organism from which we obtain the litmus. It is an indicator for the pollution also. So next one, 11th one, we have plaster of Paris, that is POP, is made by the partial dehydration of. So plaster of Paris is made by the partial dehydration of Epsom salt or gypsum salt. Is it by blue vitriol or green vitriol? Okay, very good, Varsha. Exactly, it is from the gypsum salt. So we have seen the reaction, that is by the dehydration. Plaster of Paris, that is plaster of Paris is building materials used for coating walls and ceilings. Plaster starts as a dry powder similar to mortar or a cement, and like those materials, it is mixed with water to form a paste which liberates heat and then hardens. So plaster of Paris is exactly similar to like a cement or a mortar. So it is by the dehydration of partial dehydration of gypsum salt. Okay. So 12th one, we have acid secretion is a characteristic of. Which of these have a characteristic of acid secretion? Is it buccal cavity or stomach, or is it a small intestine or large intestine? So which of these following have a characteristic acid secretion? Okay, any answers? Buccal cavity, stomach, small intestine, large intestine. Okay. So it is the second option, stomach. The stomach is famous for its secretion of hydrochloric acid. It is secreted from parietal cells into the lumen, where it establishes an extremely acidic environment. This acid is important for the activation of pepsinogen. It is one of an enzyme, pepsinogen, and inactivation of ingested microorganisms such as bacteria. So it fights against the microorganism and also helps for the activation of some of the enzymes and digestion of food. That is hydrochloric acid secreted by the stomach. Okay. 13th, we have the acid present in red ants is. So we feel some burning sensation whenever the red ants bite. So which is the acid present in them? Is it acetic acid, butyric acid, caproic acid, or formic acid? So which of these acid present in red ants? Okay, any answers out of 4? Okay, answer for option 4, that is formic acid. So it is a formic acid present in red ants. Formic acid is the simplest carboxylic acid. It is an important intermediate in chemical synthesis and occurs naturally, most notably in the venom of bee and ant stings. So it is usually present, we have already studied, that is defense mechanism by plants and animals, right? So it is a formic acid which is present in the red ants. And also we have seen methanoic acid is present in some of the bee stings. Muscle fatigue is caused by the accumulation of. So whenever we do some exercise or excessive work, we feel some muscle fatigue. It is caused by the accumulation of which of the following acid? Is it pyruvic acid or lactic acid, oxaloacetic acid, or is it uric acid? So which of the 4 acids are produced during the muscle fatigue? Okay, any answers? Okay. It is because of the second option, that is a lactic acid. Because of the accumulation of lactic acid, we have muscle fatigue. It was once believed that lactic acid buildup was the cause of muscle fatigue. The assumption was lactic acid has some picking effect on the muscles, inhibiting their ability to contract. So it will give some picking effect and lead to inability of their contract due to the accumulation of lactic acid. Okay, we'll move on to the conclusion part. In this chapter, you learned define the terms acid, base, salt, and indicator. Give some examples of some common household acids, bases, salts. Describe the properties of acid and bases. Explain the types of solution. We learned the types of solution. Explain indicators and alkalis. And we also define the pH. We also learned what is pH and recognize the importance of pH in everyday life. We learned some importance of pH in our daily life and define salts and describe their methods of preparation. We learned how to prepare the salts and also uses of baking soda, washing soda, plaster of Paris, and bleaching powder. So we learned the uses of all these important salts. So any questions or queries if you have about this lesson, you can ask me. So we learned some of the important concepts of acid, bases, and salts. If you still have any questions or queries, you can visit the edurapid.com site. You have many study materials. Go through them. If you have any queries, you can ask me.